Okay, so if we have 1/2 base times height equals a for our triangle, and they give us one piece of it, so they either give us base or they give us height, and then they'll also give us area, then it becomes an algebra problem. If they give you the base and the height, then you just plug it in, and then you would be solving for area. So for the example that we did, they gave us 1/2 b, and then our height was 6, and then they gave us the area of 36. So then we basically say, what is 1/2 b times 6? So 1/2 of 6 is 3, and then we put our b here, equals 36. Now this becomes algebra where they're multiplying 3, we divide by 3. Anything we do to one side, we do to the other. B is left on this side. B equals 12, and then you would, I forgot what the label was, but just say it was millimeters. You would label the base is 12 millimeters. When you are solving for, if you have an x and a y together, they'll tell you for y or for x. That means that the y, underline it or do something, is going to stay on the left side, and you're going to bring anything over that is not a y over to the right side. So 1/3 x is what we have on this side that's remaining that's not a y. They're adding 1/3 x, so we subtract 1/3 x. Anything we do to one side, we do to the other. This cancels each other out. Y equals, and then it's always proper to put the x first. So we have negative 1/3 x plus 4. We can't have a number or a fraction or a decimal here. So if you do, then like we did for the other one, we had, when we did all of this, we ended up with 1/5 y equals negative 3x plus 7. To get the fraction away from the y, you use the reciprocal and you multiply it. Anything you do to one side, you do to the other. So it basically becomes this whole thing times negative 3x plus 7, and it's all over 1, and we know that that just means nothing, right? If this was not a 1, then you would have something here. So suppose it was 2/5 and this was a 2, you'd keep your 2 here, but for this one it just cancels it out, so we don't have to worry about this anymore. And then we distribute this 5 throughout the whole entire problem, and so it becomes y equals negative 15x plus 35. Does that make sense now when you see it like this?
Yeah.
Okay. So part of what Mom sent me to go over was positive and negative integers and improper to mixed number, and then multiplying fractions and combining like terms. So that is a lot to put in one video. So let's try it out. Okay. So multiplying fractions, if you have 5/3 times 1/2, you're going to multiply across, and then you have to simplify. This one's already simplified. If it turns out to be an improper fraction, you have to change it. So suppose it was this over this, and it became 6/2. You would have to turn it into either a whole number or a mixed number. Does that make sense?
Yeah.
Okay. If it is a mixed number, 1 2/5 times 2 1/4, you first have to change it to an improper fraction and then multiply. So we would do 5 times 1 plus 2 is 7/5 times 4 times 2 plus 1 is 9/4. And then 7 times 9 is 63 over 9. This just happened, oh, not 9, sorry, over 20. I was adding. And then you change this to a mixed number. 63, so 20 goes into 63 3 times, 3's left over 20. Does that make sense?
Yeah.
Okay. Combining like terms, if you had 5x minus 2x plus 3 minus 1 plus 2x plus 3, you would put all of the x's together. You know how I do it. I like to pick a shape to do all of my x's, and whatever is included before the integer that's connected to the x would be in your circle as well. And then I pick a different shape to do the numbers or the y or whatever is in the problem. And again, you are going to keep whatever is in front of the number with it. So then an easy way to keep track of what you're doing is you can just write out all the x's with the negative or positive sign with it, and then as you do that, cross them out so you make sure that you do not miss anything, and then do the same thing for the numbers. So I have 3 minus 1 plus 3, 3 minus 1 plus 3. Now I know I have all of my terms, and then I can simplify. So 5x minus 2x is 3x, plus 2x is 5x. And then 3 plus 3 is 6, minus 1 is 5. So then we always write our x's first, and we write our numbers after. So this would simplify into 5x plus 5. The biggest thing that you have to deal with is that the negatives are going to be confusing. That's why I said to just go ahead and do it like this, so that suppose this was negative and this was negative and this was positive, you'd be able to see pretty clearly that you have negative 5x and negative 2x, which is negative 7x plus 2x. So you could even do this if you want, and then simplify it even further. Biggest integer wins the sign. It's negative, and then I have a negative and a positive, so it's a negative 5x. Does that make sense?
Yeah.
Okay. Let's go over positive and negative integers. So when you're adding or subtracting integers, biggest integer wins the sign. And then you circle what comes before the integer. So if you had a negative 50 and a positive 3, biggest integer wins the sign. My biggest integer is 50, so my answer would be negative. And then I have a negative and a positive, so I would subtract 50 from 3. My answer is negative 47. You remember all that?
Yeah, I remember that.
Okay, so if I had something that looked like this, I circle this becomes a positive, and I rewrite it like this. And then I do biggest integer wins the sign. My answer is negative. I have a negative and a positive, so I subtract the integers, negative 47. If I'm multiplying or dividing, then I go by the rules: 2 negatives make a positive, 2 positives make a positive, and 1 negative and 1 positive equal a negative. And then you would just multiply like normal. If you have something that looks like this, negative 3 times negative 3 times negative 3 times 4. If you have an odd number of negatives, your answer is negative. If you have an even number of negatives, your answer is positive. So this would be 3 times 3 times 3 times 4. So on your calculator, you would do 3 times 3 times 3 times 4. My answer would be 108. And then I count the negatives. I have 3, which is an odd number, so my answer is negative. If I had this, then I would do, I have 1, 2, 3, 4 negatives. That makes a positive because it's an even amount. And then my answer would be positive 108. Make sense?
Yeah, I remember like the negative.
Okay, perfect. And then improper to mixed. So if I had 54 over 20, I do 20 goes into 54 how many times? 2? With a remainder of 14. So this becomes my whole number, this becomes my numerator, and my denominator stays the same. And then I have to simplify. So what is my common number of 14 and 20? It is 2. So that is 2 7/10.
But
Make sense? Okay. Let me see what else. Did you have a question on 1.4 you said?
on number let me go back for the homework.
Mm-hmm.
On number 9, I was just confused which one is what step to do first since there's 2 variables.
So you're always solving for y. Can you see this? I can't see my screen and the book, so just let me know if I ever go out of frame. Okay, so we do have 2 variables, but they're telling us to solve for y. So remember I said take a different color. This is what's going to stay on your left side, and everything else is going to get taken care of. So if we need to bring this 4.2x over, they're adding 4.2x, so we subtract 4.2x, and anything we do to one side, we do to the other. What's left on this side is negative 1.4y. And then these cannot be combined because we have an x and we have an integer, or a decimal. So we can just simplify it to negative 4.2x plus 2.1. But we're not done yet because we have this negative 1/4 connected to this y. They're multiplying negative 1.4, so what do we do to get rid of our 1.4 from that side?
Divide.
Yep, so we divide by negative, oh my gosh, I keep breaking my pencil, 1.4, and anything I do to one side, I do to the other. And then this is a y equals negative 4.2x plus 2.1. So just like we did with the other one, we divide this into this, we divide this into this. So what that's going to look like is 4.2 divided by 1.4 equals negative 3x, but we have a negative and a negative, so we know that turns into a positive, right? And then this negative 1.4 gets divided into 2.1. So you're going to do 2.1 divided by 1.4. And we know it's going to be negative because we have a negative down here, and that also has to get divided. So it becomes positive 3x minus 1.5 equals y. Does that kind of make sense? It's a lot to look at, but we do the same exact thing. We treat it the same exact way, and there is no reason why we cannot divide 1.4 into this and to this. It may come out evenly, it may not, but it's a totally appropriate number. It's 100%.
Yeah, I just forgot that the y had to be by itself, but I understand it.
Yeah, sometimes they'll have you solve for x, in which case the x would stay. So suppose it was solve for x. Let's do, so if we did 3x plus 1/5 y equals 7. If they asked us to solve for x, we would bring the y over here. So we would subtract minus 1/5 y, whatever we do on one side we do to the other. What's left on this side is 3x. What's left on this side is negative 1/5 y plus 7. And then we would have to separate our 3 from our x. So you divide by 3. Anything you do to one side, you do to the other. So that would be the answer. And we could not simplify it anymore. So, I mean, we could. So we would do 1/5 divided by 3 and 7 divided by 3. It's totally fine. You can do that. But does that make sense? That's why I said whatever they tell you to do, kind of highlight it in your problem. So if they tell you to solve for y, bring a different color or bring a highlighter or do something and do this so that you remember what you're doing, because you're dealing with a lot of fractions and this and that, and it starts to get confusing unless you kind of call that out to yourself. So yeah, that's what I would do. And then it'll help keep you nice and organized. Let me just look. I printed out your sheets. Okay, the distributive property. So we have right here, we have to distribute this. Let me make this brighter. Okay, we have to distribute whatever is inside or whatever's outside into whatever's inside. So for this, the -2 would get distributed throughout, and the 6 would get distributed without. They make this so small. Hold on, let me make it bigger. Okay, so the first step is to distribute the -2 to the x and to the -5. So this side becomes -2x plus 10. Does that make sense to you?
Yeah.
Okay, and then this side becomes 12 minus 3x, because 6 divided by 1/2 is 3.
Okay.
Make sense?
Yeah.
All right. Now we have to bring the numbers on one side and the letters on the other side, so you can choose what to do. But I like my x's over here, so I'm going to put this 3x over here. They're subtracting 3x, so I add 3x. Anything I do to one side, I do to the other. Now I have 1x plus 10 on this side equals 12. Now I have to get rid of my plus 10 on this side, so they're adding 10. I have to subtract 10. Anything I do to one side, I do to the other. What's left on this side is x, and this one is 2. I would write that all down, because distributive property starts to get a little crazy looking. When is your test? Tomorrow?
Yeah, tomorrow.
Okay. Okay. I would like you to try number 3 on the video, and then I will go over it.
Number 3 right there.
Yeah. All right. Did you finish it?
Almost.
Okay, I'm going to start making the video for it. So we have 6 distributes to 4. It equals 24, and 6 distributes to z, -z, so it becomes -6z equals 2z. They're subtracting z. I add z on both sides. What's left on this side is 24. What's left on this side is 8z. To get my 8 away from z, I have to divide. So I divide both sides by 8. This cancels each other out. What's left on this side is z, and what's left on this side is 3. All right, Hadley, did you get 3?
Yeah, I got it.
Okay. For this one, sometimes your problems are going to have no solution. Sometimes they're going to have infinitely many solutions. So this one is 3 minus 4x equals negative 7 minus 4x. So you can decide what side you want your x's on and what side you want your numbers on. So then this one, they're adding 4x, add 4x on this side. And then what's left on this side is 3, and what's left on this side is negative 7. 3 is never equal to negative 7, so that's never true, so it has no solution. That's a totally fine answer. You would write 3 equals negative 7, and then you would write no solution. That's your answer.
Got it.
If you come up with as you're simplifying and you're doing everything, you come up with 4 equals 4. That means that that's always true, right? 4 always does equal 4. So the equation has infinitely many solutions. So say you do number 4 and it says, and I'm just making something up, 3 equals 2. That would be a no solution one. And if you had this and it equals 6 equals 6, that would be this one. It has infinitely many solutions, so you would write 6 equals 6, infinitely many solutions. That would be your total answer. So let's go ahead and try to get 4, 5, 6, and 7 done. And I will, anything else that you need me to go over?
I think I'm good.
Yeah, this was so much to pack in one session.
I don't know.
Okay. All right, so for this one, I'm going to bring my 1 over here. Anything I do to one side, I do to the other. I'm going to bring my 2x over here. So this cancels each other out. What's left on this side is nothing. What's left on this side is negative 2. So that's a problem. Okay, 1/2 equals times 6t minus 4 equals 3t minus 2. So you're going to distribute this. It's going to become 1/2 times 6t, which is 3t, minus 2 equals 3t minus 2. So I'm going to add 2. Anything I do to one side, I do to the other. And what's left on this side is 3t plus 2. What's left on this side is 3t. I'm going to bring this 3t over. Anything I do to one side, I do to the other. Make sense?